This 9.5 is kind of a short section. You're going to see a little bit shorter of a homework session here. So let's look at some additional information. Let's look at absolute values, piecewise functions, and then a special type of piecewise function, which is called a step function. To graph an absolute value, you're always going to have a v, because absolute values are going to be symmetric about the y-axis, because when I plug in a negative x value, I'm going to get the same value as if I plug in a positive x value. So it creates this nice v function. So when I'm graphing the absolute value, there's a vertex, just like there is with a parabola. So if I'm looking at the vertex for this absolute value, it would typically be at 0, 0. Now, what have I done here? I shifted it left 1, up 2. It's the same shift that happens with the parabola. Left 1, up 2. Notice there's a negative symbol in front of the absolute value. So that's going to make it negative and open down, just like a parabola. The only difference is I have a corner instead of that nice curvature happening here. What are other piecewise functions look like? So a piecewise function is one function that's described by multiple equations, and there's inequalities that limit them. So this is a pretty big explanation. This is how I would do these functions. I would take out a sheet of paper, and I would graph the entire function. That's how I do this, okay? So if I graph this, I would graph the absolute value of x minus 1, which I would show the other side of that graph right here. So the absolute value of x minus 1 would be that huge v. Then I say, well, it's x is greater than negative 1. So I go to negative 1, and I erase everything that's not greater than negative 1. That's why this whole corner is gone. Then I'm going to graph x minus 1, which is a straight line, which goes through here. You can use Desmos.com, guys, to help you graph this as well. And then you're going to erase everything that is not less than or equal to negative 1. So I'm going to erase everything here on that line. Now, how do I know open circle versus closed circle? If it has an equal to, it's going to be a closed circle. If it does not have an equal to, it's going to be an open circle. So this is kind of like taking two graphs and putting them together into one, because you've erased parts of a graph and you're using a different equation for those. This is an example of what we're looking at here. We're analyzing a piecewise function. So what we just learned in the previous section is if I take a ride on this function from left to right, I'm pretty constant here. I mean, it might be increasing very, very small, but I'm a pretty constant here. And then it's going to be decreasing all the way down during these years. So where am I getting 2x plus 799? Let's go back here. I can find the slope between 2 points, and I get, oh, it says use the models. There we go. So it's right there. But I could also find this the hard way and do the slope here. But I have two models with two equations. So this is how I do it. I'm going to get the y values. That's what I'm doing. I'm plugging in. And I'm going to be able to graph 2x plus 799. And then I'm going to graph negative 27.2x plus 974. And I'm going to go back and erase. So I'm going to erase anything before here, since I want to find the number of oldie stations between 2002 and 2008. Then I'm going to erase anything else from after 2013 for here. So it's kind of a complicated concept in the lab. Most of what we're doing is better done on paper and then looking back at the lab with that erasing function. So if I want to do 2002, the model is y equals 2x plus 799, so x would be 4 in 2002. Because I started in 1998, I'm ending in 2002. So my y value is 807. For 2008, we have to use the other model it tells us to use, and that would be 10 years from 1998, so I'm plugging in 10. Then I have the y value of 702. So what this is just telling you to use two different equations depending on the actual year that it occurred in. Step functions are unique. This is kind of a weird symbol here, and it basically means step. So if I'm at 12, I'm going to be at 12. If I'm at 3.7, I'm going to round down. Ooh, that's tricky, right? Because we're so used to rounding up. With the step function, you round down. So negative 9 remains negative 9. But negative 6.2, you round down. Are y'all catching that? Down from negative 6 is negative 7. Which is weird, right? But we're rounding down. 1.5. or the step on either side is telling me to go up to 2. 3.14 notation is on that left, we're rounding down. So that's called the greatest integer function. So what do these actually look like? So if you go into Desmos.com, you can actually graph these. And so this is why we're rounding up and down, because this is where we wind up. If I'm anywhere on here, I have to be at 1. So I can't actually be up here at 1.5. I'm going to have to be down here at 1. When I look at this, the domain is going to be all real numbers, which looks very strange, right? Because I have all these open circles. But for every open circle, there's a closed circle. And then my range is just those exact values. Now, I don't want you to get stressed out and think, oh my gosh, these are so hard in the lab. There's very few of these in the lab. You're going to be able to use Desmos.com to graph this out, to take a look at it. If I wanted to graph this, I would go to Desmos and graph the greatest integer of 3x and then subtract 1. Because this process is going to be tedious by hand. It is. So I would go and graph that in Desmos.com. How does this look in real life? So let's suppose the post office charges 80 cents per ounce, or a fraction of an ounce. So even if you're at a fractional ounce, you still got to pay 80 cents. So if you have 3.3, you got to pay 4 times 80 cents. This function is similar to the greatest integer because we have to round to that 80 no matter what the percentage, no matter what the amount is over 1 ounce. So if it's 1.1, we owe $1.60. So it's very similar to the greatest integer function. So we can kind of write this out as a similar or step function, because if I'm anywhere between 0 ounces and 1, I'm paying 80 cents. If I'm anywhere between 1 and 2, I'm paying $1.60. If I'm anywhere from 2 to 3, I'm paying $2.40. So this is kind of about rounding and having that step function.